Okay, so I hope this this is still working. And okay, so we can filter rows. So it's very much like subset. Again, you just apply these conditions here. Okay. Okay. So so that is filter. If you wanted to select by row number, okay, so somehow you knew you wanted like row 1000 or something to row 1010, then you use the command slice. Okay, so slice will select by row number. Okay, you can also with filter you can put in or commands there also as well. All right. Is that okay with everybody? All right. Then whatever you have, you can also sort the data. Okay. So perhaps we want to sort based on carrier. Okay. So we can do arrange flights based on carrier, and then maybe month, and then day. Okay. And then so it says you've got carrier 9E, which I think if I do look up airlines over here, it tells me, let's do view airlines. So over here it tells me 9E is Endeavor Air, okay? And so here I can sort based on carrier, and these are all the flights on January 1st or something like that, okay? Of course, so dplyr works very well with the Magritte pipe function, okay? And if you hit Control-Shift-M on your keyboard, that inserts pipes, so you don't have to constantly type in percent greater than percent, okay? You can just hit Control-Shift-M, like for Magritte or Magritte, and pipe that in. So you can, you can say flights, let's filter, okay? And when you have filter, you don't have to constantly say flights. You're going to pipe the output, which is flights. So you're going to say, let's filter where carrier is equal to 9E, and we'll do day equal to 1. Okay, so we're just looking at the first day of the month, okay? And then let's arrange this by month or something. I don't know. Let's see what happens. Oh, well, of course that happens. Let's arrange by departure time. Okay. All right, and so we see on March 1st we had a flight at 6 a.m. On February 1st we had a flight at 6:10 and things like that. So this is we're sorting based on departure time, and then you can add more things to arrange to break ties. So you can say, we'll break ties based on I don't know, the month or something. Okay, so this is just a very silly situation, but you can see it makes a small difference here, where we had 6:55 and it lists the 11 and then it lists the 7. But here, now that we said arrange them by month, it sorts them appropriately. Okay, and it works very fast. dplyr is very quick at carrying out all of these operations and commands that you give it. Okay, so is this so far okay? So filtering and arrange, so that selects rows and then it sorts them based on the criteria you give it. Okay. Yes. What is what? What is dplyr written in C? Yeah, partially written in C, and it's a mix of C and R. Okay. Maybe I'm gonna extend my table view thing so we can get all of the columns here, okay? So anyway, this is kind of a neat some stuff. Why do I should just close this out. Yeah. Okay, so we can also here we've got 16 columns. Maybe we don't want all 16 of these columns. Maybe we're not interested in some of this stuff. Okay, so then we can do select. Okay, so we say select from flights. I want you to select departure time and departure delay. Okay, and it says okay, I'll do that. Departure time and departure delay. Okay, if you look up the help on select, select dplyr, okay, then you'll see it gives us some special ways to select things. Okay, we've got starts with and ends with, and I don't know, something's wrong with my help viewer here. I don't know. It's unfortunate, but so you can do something like select from flights columns that end with delay. Okay, and then did I mess something up? Oh, ends with. See, your spelling is important. Okay, so ends with delay, and it says, okay, I found two columns that end with the word delay. Here's departure delay, and here's arrival delay, or things like that. Okay, or you can say ends with the delay, or ends with time. Okay, and it says, okay, I found a bunch of columns. Okay, and these end with delay, and these ones end with time, things like that. Okay, so again, if we look at our flights table, we see all of these things, and you can also just say from flights select columns 4 through 7. Okay, just like before, so that will take this. Or let's say you want year through day. Okay, you can also kind of almost like almost as if they were counting these things. You put the colon here, and it says year through day, and it will say, oh, here you go, year, month, day. Okay, so it recognizes that when you put the colon here, you're kind of saying take it from year through day. So selecting columns, and make it really nice and easy to kind of select columns very quickly based on what you want. Yes.
Sorry, what is the percent for your 39%?
So it's the pipe. So when I did select year day, so normally you'd have to write select, okay, parentheses, from the flights table, year through day, okay? So that's one way, but what the pipe does, it says take flights, feed it into this command or this function as its first argument, okay? So when you do that, it takes whatever is output over here, which in this case is just the entire flights table, and it feeds it into the first argument, and it puts a comma in there for you, kind of. And so you just have to kind of give it the additional arguments. You don't have to constantly do all of this stuff here. Yes?
So these functions in dplyr don't actually do anything to the actual data set? Do they just generate, say, this?
Yeah, it's not, it doesn't change the original thing, okay? So what it returns is it says, so you got flights, and you do this, okay? And what you end up getting back is a new table that has 336,000 with 3 columns. However, we haven't assigned this to anything, right? We did flights, select year through day. So then as soon as I've done typing that, it dies. It's like it shows up and it dies. If I want to store it, okay, then I have to do something like flight dates, okay, and then I can do the assignment operator, and then, oh, I have to take it, and this would be the output of whatever is the thing, okay? And you can, so this feels a little bit funny, but you can do a chain of these things, okay, and whatever is at the end, then if you want to save it, then you know, whatever the save object, whatever you do, you do this, okay? So the way R would read it is it runs all of these things. After it gets to the end of it, and you want to save whatever that is, then it goes, it takes the final result and saves it into this object. So it feels a little bit funny because you're not putting the save thing at the end, you're putting it at the beginning, but it's okay. It understands. It's going to run through all of these things. Whatever that is, save it into whatever you assigned it. Okay? All right, so yeah, so you're not changing flights at all. Okay, so that is...
This is going to be a really dumb question, but let's say you have a huge table and
Yeah.
connected to it. Remember we talked about the use case where you're running against system resources and you want to splice it. Is it possible to use this without loading the original data set completely in memory?
Yeah, so you know, I'm not entirely sure about the intrinsic workings of dplyr. I just know it's very fast. So I think it does what's called lazy operation, where it knows, you know, I'm not going to display more than the first 10 rows by default, okay? So I'm only going to do the calculations that I need to produce this output that I want. Only when you say save it into something like this will it go through and do all of the hard work in calculating all of this stuff. But I'm not 100% sure how it works. I just know it's fast, that it's never been an issue for me to have it do all of these things and then say, and then store the results. Okay, so you can select columns, and then I gave you kind of just a brief thing with, you know, starts with or ends with and things like that. Okay, so here I'm going to show you. You can rename column names using the command rename if you need to. Okay, but yeah, let's look at this distinct thing. Okay, so from distinct, inside distinct, you would say you would take flights, and you would say something like select. What do we have here? Destination. Okay. And if we do that, you know, it gives me back the entire data set has 336,000, and every row has a destination, so it does that. But if we want to just figure out which ones are, how many there are total, I just throw it into the command distinct, and it says, oh, there's now only 105. Okay. But if I did something like select destination and month, okay, then it's going to create one row for every unique combination of destination and month, right? So I'm going to have, so essentially this number is approximately 12 times this number. It's a little bit off because, you know, maybe nobody flew to, I don't know, a certain destination in the month of August or whatever, right? So maybe, so it's not quite 105 times 12, but it goes through in the entire table and it figures out how many distinct combinations are there of these two columns that you selected. So that is distinct, okay? And so we can do how many distinct pairs of origins and destinations are there in from New York, okay? So we can see, you know, from LaGuardia to wherever, you know, whatever this is. I don't know. I don't know airport codes. So what is what's EWR? I should look up airports. We can do view airports. Okay, so, oh gosh, there's so many of them. 1,300, 1,400. Okay, well, anyway. Well, there we go, Burbank for Bob Hope Airport. But this is useless. It just says Bob Hope Airport, but only if you lived in California or LA would you know that was Burbank. So, where's Burt Mooney Airport? Nobody knows, right? You'd have to, yeah, this is not as useful as I was hoping. Okay. Adding new columns with mutate. Okay, so here you would create a column. The column that we are naming is going to be called gain, which is going to be the arrival delay minus the departure delay. Okay, so how much time did we gain? So if the arrival delay, so this is, it's scheduled to arrive at noon. You get the flight lands at 12:05. Your arrival delay is 5 minutes. Okay, and let's say it was scheduled to leave at 8 a.m. and it leaves at 8:10. Okay, then your departure delay is 10 minutes. And so if you end up less than 10 minutes late at your arrival delay, that means in your flight you gained some time, right? They made up for the lost time. So we can do arrival delay minus departure delay, and if we apply this to flights, we see it adds these columns, which here. So I'll run this command here. So I'm going to do mutate flights here, and let me expand our. So it adds the two columns, gain and speed here. Okay. Which speed is kind of a loose calculation of. If you see, it's the distance we traveled divided by airtime multiplied by 60, because I think airtime is in minutes, so now we multiply it by 60 to get it into miles per hour, right, instead of miles per minute. So something approximately like this. Okay, and the neat thing about so there is a function in R called transform, but the neat thing about mutate is that if you name a column gain, you can use that in future calculations in the same operation. So you say, gain is going to be arrival delay minus departure delay, and then on top of that, I want to use that value and do something like calculate the gain per hour, which is going to be, this is a silly thing to do, but you can do that. Whereas the built-in command transform will say, I don't know what you're talking about when you say gain, okay? And then there's a small distinction. If you only want to keep the new columns that you created, then you use transmute, okay? But you could just do mutate, and then you can pipe this into select, where you're just selecting the new columns that you want also. It's the same thing, but you can save a few keystrokes if you remember all of these other things. Okay, you don't have to remember all of these things. I think just the verbs that you should know are these ones right here. Okay, these ones I'd say are the most important ones. The extra ones that kind of show up in this little help file. You don't have to know every single one. Okay. Summarize. Okay, so summarize is super helpful in that it takes the entire thing and then it will calculate something like the mean, okay? And you have to name each column. So if you want like the mean delay, you do delay is equal to the mean of departure delay, and then ignore the missing values, okay? So keep that in mind. Summarize will return a data frame that only has one row, okay? So we're going from 336,000 to 1, which is how, things like aggregate functions like the mean work, okay? So I could do something like summarize. Oh, and notice that summarize is spelled with S because Hadley is from New Zealand and they spell things the wrong way. over there. So take flights, and so if we want to say mean, and we're going to do departure delay, and we're going to ignore the missing values. We can also create more things to summarize. So we can do arrival delay, which is going to be equal to the mean of arrival underscore delay, where we are again ignoring the missing values. Okay, so how many columns and how many rows will I have when I run this command? Two columns and one row. The columns will be delay and the columns will be arrival. Okay, delay and arrival, and I only have one row because I'm taking the entire data frame and turning it into one row. Okay, when we apply this thing called group by, that's where this gets really cool. Okay, let me just make sure. Okay, so and then we have randomly sample rows, which dplyr makes it super easy. So I think in like your first homework assignment, I had you guys randomly sample rows, and if you didn't use dplyr's sample underscore n, you might have realized it's kind of a pain in the butt to randomly sample rows. You gotta say sample some integer values from 1 through the number of rows that you have, and then once you sample your integers, then you select the rows based on those integer values, which it's not too terrible, but it's a few extra steps. Here you just say, go to flights, pick 10 random rows, boom, and it does that for you, okay? Or you can say, I want you to pick 1% of the, do sample 1%, you can use sample underscore fraction, but sample underscore n, probably good enough. If you're gonna, you can also turn on replace equal true in case you're gonna do some bootstrap operations later on. All right, is that okay? Yes?
Does the function sample parentheses flights size equals n?
So yeah, it will not do what you expect it to do, okay? Because when you, if you, it says flights, take a look at dimension of flights. It has 16 columns, okay? So if I say sample flights 3, what it's going to do is it's going to select 3 random columns.
Yeah, that's what that was the problem.
Yeah, so when you, if you try to do it this way, it's not going to work. What you want is sample underscore n, okay, and it's going to pick 3 random rows. Yeah, so, because if you just say sample flights 3, it's going to pick 3 random columns, which is probably not what you want at all. Yeah, that's the built-in sample function because R handles subsetting based on names as subsetting the columns. Okay, so just some things to keep in mind with those verbs is that the first argument is always the data frame, okay, which if you're going to use the pipe operator, then it's nice because you can just pipe it and then you could ignore that first argument because it's always going to be the data that's being fed into it, right? So you don't have, so if you just do that, you can ignore the first argument because Magrider defaults to putting the results into the first argument, okay? And then the rest of the arguments describe what you want to do to it, okay? And the result is always going to be a new data frame. So if you want to store those things, then you have to tell it to store it somewhere. And so when Hadley designed this thing, he tried to think of what can you do to a data frame, and he boiled it down to just a few verbs, okay? So if you have a tidy data frame, there are only really five things that you can do to it. You can reorder the rows, which you use arrange. You can pick observations in variables of interest, which we use filter and select for. There might be new variables that are functions of the existing ones, which we use mutate for, right? Maybe you calculate ratios and averages, or not averages, ratios between columns or differences that will be used mutate. Or you can collapse a bunch of those variables or values, rows, into single ones, and that's what we use summarize for. Okay, and everything else is just kind of you know, a series of these operations applied to it. Okay, so this is the cool part that I really think is you can use this command group by, and when you group by something, it kind of just arranges things, but it doesn't seem like there's a huge change, but internally it keeps track of what you requested to group by. Okay, so for example, I'm going to take our thing flights, and I'm going to group by, and we're going to do carrier. Okay, what happened? Am I going crazy here? Carrier, why is it? Okay, or actually, it doesn't even sort it. It just says, it looks exactly the same as before, but it says, you know, we've got 16 groups here. Okay, now here it doesn't look like anything has happened, right? But let's take this and let's now pipe this into our command summarize. Okay, and let's do mean. Oh no, not mean. We want to create a column called delay, and this is going to be the mean of departure delay, where we ignore the missing ones. Okay, so after I've grouped it and I feed it into summarize, what this is going to do is it's going to, rather than collapsing it down into one row, it's going to collapse it down into one row per group. So we're going to have 16 rows here. Okay, and so it says, oh, here you have, so you've got 16 carriers, and these are the summary statistics for each of those things. Okay, this is, I don't know if you guys realize this, if you tried to do this without dplyr in R, it's a huge, I mean, it's possible, but it's a lot of work. Okay, and so you can apply a lot of these summary type functions that take a whole bunch of numbers and boil it down into one, and all you had to do is just add one extra thing, which says group it by carrier. All you have to do is just in between flights and the summarize thing that you want, you just add this thing and you say, you know, group it by this thing. Okay, you can add multiple layers of groups too. Okay, so if I wanted to group it by carrier, and then I can group by month. Okay, and we can see what? Okay, so here we have, what did I do? I think I screwed this up. Don't look at this one. Okay, so here I have grouped it by carrier and month. Okay, and it says this was the departure delay for carrier in month 1, month 2, month 3, and things like that. Okay, so you can group things, that way. Okay, but probably, you know, just pick one of these. One of these things, so you can group by tail number, which is like a unique airplane. Okay, and then we're going to summarize doing these things, and we can then filter. Okay, and then this creates a nice, you know, a plot here. Okay, but so we can take flights, and we're going to group it by tail number. Okay. And then based on that, we're going to summarize it, and we're going to calculate the count to just see how many we have. the distance that these things traveled on average and the average delay, okay? And so we had a total of 4,044 unique aircrafts, okay? And we can see that this aircraft had 4 flights in the year 2013 from New York, okay? This flight, on the other hand, had 371, okay? So that means it was flying out of New York probably every single day, and or if not every single day, multiple times a day out of New York, okay? And then, others, traveled, 50 times out of New York or whatever, okay? So you can group by things and then apply summary statistics to the groups. When you do a group by in of itself, it doesn't seem like it did anything to the table, but it's extremely powerful when applying summary commands, the summarize command. You can further group things. Okay, so I'm going to run this here. So here we're creating summaries, statistics on each destination. Okay, so I said group by destination, and for each destination, count how many distinct airplanes we had. Okay, so we're saying the number of distinct tail numbers, and then also count the number of flights. Okay, so I'm thinking this is Albuquerque. We had 108 airplanes and 254 flights to Albuquerque from New York in the year 2013. And as we go through these things, you can apply even more layers of grouping here. Let me find an example here. Okay, so here we are. This is the application of group by. So we're going to group by city, and in turn returns one row per grouping. Okay. Okay, so here we are grouping on two variables, and let me see what I can do here. Sorry, we're going to do flights. We're going to group by we'll do destination and tail number. Okay, and we've got we're grouping by destination and tail number, and then what we're going to then do is I'm going to summarize, and we're going to just count how many flights each of these things did. Okay, so here I'm summarizing. So I grouped by destination and tail number. So these are kind of just unique combinations of the destination. So to Albuquerque, this particular aircraft flew one time in the year 2013. This particular aircraft flew to Albuquerque 4 times in 2013, and so on. And we can do this. We can further summarize this table. Okay. just and count, because the if we look at this, see it says the groups are destinations and tail numbers, and over here it says now that we've summarized based on destinations and tail numbers, there still exists another grouping variable, and this is destination. Okay, so if I feed the results of this table into another summarize function, it's going to return a summary based on the total destination. So it says you had a total of 108 unique aircrafts flying to Albuquerque. Okay. If we wanted the total number of flights, I would then have to do I would have to summarize or sum this column. Okay. So n is just the count of how many tail numbers, different tail numbers I had going to Albuquerque or ABQ, wherever ABQ is. I'm hoping this makes sense. Okay, so when I took my flights and I grouped it by destination and tail number, and it says you have 44,465 of these groups, which is each row here is a unique combination of the destination and the tail number. So each of these tail numbers each of these aircrafts are different, but they all went to Albuquerque, at least in these first 10 rows. And that's because it has counted how many times each of these things showed up. If I further summarize this table, then it's going to count how many different rows do I have that correspond to the grouping of destination, Albuquerque in this case. And so here we would say we had 108 unique aircraft going to Albuquerque, and here we have 58 unique aircraft going to ACK. I don't know where that is. Somewhere. Okay. Is that okay? So you can. So anyway, the grouping and the summarize combined together, I think, makes for some really powerful operations with dplyr. Are there any questions on anything? No? Okay, well, I think we'll end our tutorial there then, and I'll post all of these resources online that you can kind of go through at your own pace to make sure you understand. I'll post also a link to Garrett's presentation that he did, which is like maybe it's very long and thorough, but it's also good. So anyway. I hope these packages will make your data analysis easier as you use them. Okay, we'll see you guys on